Okay, so what we have to do right now is prove angle A is congruent to angle C, given the information that A and ADC, or angles A and ADC, are supplementary, which means they add to the 180, and same with C and CDB. So that would mean that the measure of angle A plus the measure of angle ADB equals 180, and we can write that same thing over here too, but only with this. So the measure of angle C plus the measure of angle CDB equals 180 degrees. So we know that, and the last information that we're given, bit of information that we're given, is that line or ray DB bisects ADC. So that gives us the information that these two angles right here are congruent. So I'll just draw a line there, and then so that means that they're congruent. And now what we're gonna have to do, so now since we have to prove this is this, the way we do that, to prove it, we first look at these two right here, and we notice that they both equal to 180. So that means that it is possible to write down the, the measure of angle. I'm just gonna write BAD, so that's BAD, that angle, plus the measure of angle ADB is equal to this right here, since they're congruent, they're both equal to 180. Well, never mind, forget the congruent bar, but they're both equal to 180, so we can also write, oh yeah, so this is the measure of angle, here I'm going to write BCD plus the measure of angle CDB. So then we can also always think of this as a linear equation almost, or is that because they're equivalent, so we can almost solve as if we were solving for x, but instead we're solving for the A and C. So one thing that we know, because ADB and CDB are congruent, that means they're equivalent to each other. So we right over here, we can just write like something like the measure of angle. Damn it, get out. Anyway, we can write the measure of angle. We can write the measure of angle ADB or AD. Damn it. Anyway. Oh, damn it, I hate them. Anyway, the measure of angle DAB. Dang it, I lost. Oh, yeah, because ADB is congruent to B or CDB, then those two are equal. So if we just write over here, I'm just going to write the measure of angle ADB is congruent. That's a congruent sign right there to the measure of angle CDB. The paper's moving, but yeah, that's that CDB right there. I'm gonna make that D a bit better. This paper's hard to work with, But, so yeah, we write that, then right here we have, since ABD, those two are congruent, we can substitute ADB for BCD, or we can substitute BCD for ABD, or ADB. Wait, never mind. Because these two are congruent, we can substitute ADB for CDB, or CDB for ADB. It doesn't matter because they're equal to each other. So let's just rewrite the equation like this. So the measure of angle BAD plus the measure of angle ADB equals the measure of angle BCD plus the measure of angle. Now, since we're substituting CDB for ADB, we can put in the measure of angle ADB right here because they are equal to each other. So then if we just act like this is an equation, normally we can subtract the measure of angle ADB. And we can also send over here to subtract the measure of angle ADB. So now we get this right here. So the measure of angle BAD equals the measure of angle BCD. So then there we have that. We have proven that this angle measure right here, BAD, is congruent to BCD, this process. So we can write therefore the measure of angle A, which is that right there, is congruent to the measure of angle C. And then we can just finish it off with two beautiful lines that look like that. That means that it's done. We have successfully proven that this and this, those two angle measures are congruent. So that is how you prove things.